At an instant of time, okay, this is about the wheels. Hmm. So the liquid here will rush, no? And let the level of liquid in the container be H. Now, how the thrust force will act in this direction. What is the container? The container will be moving like this towards right. And let UR be the velocity of Flux with respect to container, because container at rest will become absolute velocity. Now the container will be moving because of thrust force will accelerate. Because of acceleration, the container will be moving. So what is UR now? Velocity of Flux with respect to container, or velocity of emerging liquid with respect to container. Okay, let's get into this one. So what is UR? I think we are very sure what is UR. UR should be equal to root of 2GH. Any flow rate, can we write it here? Flow rate, let rho be the density. So flow rate, Q should be equal to area of cross section of the hole, area of cross, A naught is giving. That of the hole is A naught, no? What is the flow rate? How you define? Rho into rho A V square, no? Into U square, UR square. So sorry, only flow rate. Flow rate should be equal to UR into A naught. Then the rate at which the amount of liquid is decreasing in the container. Rate at which, okay, now rate of mass of water decreasing in container. So shall we write dm by dt? So for this, shall we write this dm by dt equal to q into rho? Q is the volume of liquid that is emerging per second. Into density, I'll get the dm by dt. So what is Q? UR A naught into rho. Keep this in mind. Can we write the thrust force now? What is the thrust force? Thrust force should be equal to UR dm by dt. Dm by dt is what? UR A naught rho. I think already we know. Once again, so this thrust force only will accelerate the container, no? M into dVc by dt. What is M? Mass of the liquid, A rho AH rho dVc by dt equal to UR square A naught into rho. A naught, okay, the rho gets eliminated. So this dVc by dt should be equal to UR square. What is Vc? Rate of change of velocity of container. Vc is what? Velocity of container with respect to ground. UR is velocity of Flex with respect to container. What is UR square? should be called 2gh. Let me substitute here dvc by dt. UR square equal to 2gh a naught by ah. So this will get cancelled. Look at a naught, a 2g. They're all, you know. So this is acceleration of container. This, I think, the thrust force, you need not to do this much. Directly what happens, thrust force, what you can write. Rho A naught UR square, rho A V square. Already we derived it. Write it here. Then this thrust force only will accelerate it, m into dvec by dt, m into rate of change of velocity of container. So if you're getting confusion, simple, rho A naught UR square. Finish. This thrust force only will accelerate it, m into dvc by what is m, mass of the liquid in the container at any time t. Solve it and you'll get the, and dvc by dt will become acceleration of container. Directly you can start from here. Just I wanted you to think, because the amount of liquid at any time t decreases. So what is the type of motion the container describe? Uniform accelerated motion. And you know what is the time taken to empty the tank? And you know uniform accelerated motion. Apply equations of motion and calculate the velocity. I'll leave this part for you. Let me discuss last one more. If this is a jet having area of cross section